what is the Uno platform and what problem does it address? So the problem that we're tackling is the problem of multi-platform application development. So everybody knows that these days there are a lot of platforms. Just for desktop operating systems, you've got 3 different incompatible operating systems. You've got 2 major mobile operating systems and ecosystems. You've got the web as well as a very important target for applications. And all of those target platforms have different native frameworks for building applications. So they've each got their own UI framework. They, for the most part, all use different programming languages. And what that means is if you want to build the same application on multiple platforms, and these days it's arguably the rule more so than the exception to be targeting multiple platforms when you set out to create an application, even in the case of smaller applications or internal line of business applications. It's often a requirement to target multiple platforms these days. What that means is that if you try to build them all using the native framework, then you're using multiple programming languages. You're effectively writing the same application out n different times for n different platforms. And there's a related problem to that, which is of migrating legacy code from one platform to another. And particularly common use case, particularly for businesses, is bringing applications that have hitherto run on the desktop to run often on the web, or in some cases running on legacy web technology like Silverlight, may it rest in peace, into more modern and supported web technologies. So what's the solution for that? The solution is a cross-platform application development framework. So what you would like to do is build your application once and deploy it to every platform that you're interested in or might eventually be interested in. So that's what Uno is. It's a cross-platform application development framework. And what sets Uno apart from other cross-platform frameworks is that it lets you write your application in XAML and C# and target basically every platform out there. So Windows, Mac, Linux, Android, iOS, and the browser, running natively in the browser using WebAssembly. So let me give you a quick introduction to Uno and explain where we've come from and where we've come to. So Uno started life as an internal framework at Inventive, a mobile agency in Montreal, around about 2013. It was originally targeting Android and iOS only, and so a lot of apps were created with Uno for iOS and Android. And in 2018, we saw what was happening with WebAssembly. So WebAssembly was a new way of running all types of code, not just JavaScript, in the browser natively, supported on all browsers and within the security model of the browser. So there were no security problems as there were with earlier third-party solutions like Flash and Silverlight. And we saw that .NET was being, well, at the time, Mono was being brought to WebAssembly by the Xamarin team. And we thought, let's try and run Uno in the browser. So we got Uno running in the browser using WebAssembly, and we open sourced Uno at the same time. There are a lot of developments since it's been open sourced. A lot of movement in 2020. In particular, we added support for 2 new platforms, macOS and Linux. We've been steadily improving the WebAssembly support. We added with the Uno 3 release support for the Fluent UI and material design systems, and still going fast in 2021. We've just released the 3.5 release of Uno at the same time as the WinUI 3 Preview 4 was released. So the common question right about now is, okay, so how much is this going to cost me, or what's the business model? What's the catch? So Uno platform is free open source software. It costs you nothing to use. You can build an app right now in it. You can do whatever you want with it. The way we sustain Uno development is the Red Hat model, or the same model as Red Hat Linux of offering paid enterprise support contracts for training, POCs, priority bug support, and things like that. So let's talk a bit more about how Uno works. So the first thing to say about Uno is that it is completely compatible with the WinUI or UWP framework from Microsoft. So what that means is if you have, for example, an existing UWP application, you can bring that code into Uno and it will just work. And what it means is if you create a new Uno application in Visual Studio and you run it on Windows, for Windows, Uno is just going to get out of the way. It's just a UWP app or a WinUI app. You can target either Uno, you can target either UWP or WinUI 3. For other target platforms, Uno is running on top of Xamarin for iOS, Android, and macOS. It's running on .NET Core on Linux, and running on Mono in WebAssembly in the browser. So to say a bit more about what that means, Uno is it's not only bringing your application code to every platform, but it's also creating a native application on every platform. So we're tapping into the native UI framework on each platform. On iOS, we're using UIKit. On Android, we're using Android Views. In the browser, we're creating native elements in the DOM. So I want to talk a bit more in that regard about where Uno fits relative to other cross-platform frameworks, and about our strategy and our philosophy for rendering views, because this is a key consideration for understanding what the framework is doing and what it's trying to do. So you've kind of got two ends of the spectrum. On one end, on the green side here, we're talking about specifying your application's behavior at a high level, but letting the target platform decide how to actually render pixels on the screen. So you would, for example, declare a button in your markup, but on iOS, you might get a blue label for the button, and on Android, a little gray block. So the idea in that approach is to leave decisions as much as possible to the target platform. On the other end of the spectrum, you've got the philosophy of basically telling the native platform to get out of the way as much as possible. So saying to the target platform, okay, give me a canvas, I want to draw pixels to the screen, and just leave me alone. So these approaches both have pros and cons. Generally, it's an advantage to be able to control every pixel and to have the application drawn on screen exactly as you want it and expect it to be drawn. But the downside, if you take the canvas approach, is that it's then harder to tap into native behaviors of the target platform. So if you want to access native gestures, if you want accessibility support, even something as simple as copying and pasting into a text block becomes that much harder, and you find yourself reinventing the wheel quite a lot. So where Uno sits is a middle point where we've chosen to, by default, draw views exactly the same way on every platform. So we control the rendering at a pixel level. So if you declare a button in XAML, it will look the same by default on iOS, Windows, Android, in the browser, everywhere. But we're still using native views, as I mentioned. So we're using the UI kit on iOS, the DOM in the browser, and so on. But we're using the visual primitives in those frameworks. So we have pixel perfect control, but we also have easy access to native APIs of the platform. But one interesting thing to note is that because we're using the WinUI contract, which has a very powerful styling and templating engine, it's very easy if you don't want that, if you actually prefer to have your application look different and more native to each platform, you can easily enable that with a line or two of code. It's just a matter of changing the default styles in the application. So I think that's a good point to actually run some code. So I'm going to create a Uno application in Visual Studio, and we're going to see how it works. Now, I don't know if everyone's familiar with the UWP or WinUI application model. So I'll show a basic demo with data binding, hot reload, and then we'll see everything running with Uno as well. So select cross-platform app template. I've got this one already installed, but if I didn't, it would just be a matter of going to the extensions, going to the extension marketplace and searching for Uno. And the first result will give you the option to install Uno solution templates for creating a new application or a new library. So here's the welcome message I get. So there's one thing we're doing with Uno is that we're pushing hard on what Visual Studio supports. So there's always an issue or two in each Visual Studio release. So we keep track of those, and we list tips and workarounds here so that you don't get stuck. So if we look on the right, this is my Uno solution. So the way it's structured is that For each platform that I'm targeting, I have a project. And the actual application code all lives in a shared project. So it's important to understand how shared projects work in Visual Studio. They're really not projects at all. They're really just lists of files. So this is not going to be compiled to a binary itself. It's just these files are going to be compiled as part of each project that references them. So you can see there's a lot of projects because there's a lot of supported targets. I'm gonna unload these. We don't need all of these right now. So we'll run on Windows first. So we've got our XAML. So we've got a text block. I can run right now and see my application. Give it a little time. There it goes. So one neat feature about XAML is data binding. For those of you who are not familiar, data binding basically is the way the main way in XAML that you pass data from your model to your views, from your views to your model, and even from one view to another view, which is what we're going to do now. So we're going to add a text box. I'm just going to put this on one side so you can see that the app is actually still running. We're going to add a text box. I'm going to put this in a stack panel because we just need a simple layout for our purposes. Put it in the center of the screen. Okay. We'll put some placeholder text so we can see our text box. So now you can see that that's appeared. And now I'm going to data bind the text in the text box to what the text block is showing me. So I'm going to give this a name. I'll add my binding here. Element name equals text box. Path equals text. And it's not doing anything. Have I done something wrong? Apparently I have. Okay. Let's try restarting, see if that's what it needs. So it was working before, I swear. Okay, so now it wants to work. So we can see that we can data bind between our elements. So that's in Windows. Now let's see it running on the web. So I'll load in my WebAssembly project. I'll launch that. Now, if we look at this project, It's actually just a .NET standard project. So so it's a .NET Standard 2.0 project, and it can consume basically any .NET Standard 2 libraries, as you would expect. Okay, so there's our application now running on the web. You can see that the data binding works in the same way, and hopefully this time the hot reload will also work for me. Okay, so if I modify the foreground on the text block here, it will update now in my live view in the browser. So that gives you a taste of how Uno works. So what sort of features from XAML does Uno support? Essentially, a pretty rich set of features, most of what you would get in a WinUI or UWP application. So the styling engine and templating engine, conditional XAML is an important one, since in some cases you want to show different visuals or have different behavior on certain platforms. Perhaps you want the button to have a pink background on Linux and a transparent background on iOS. You can easily integrate native controls into XAML because it is just running on the native UI frameworks under the hood. You can do animations. You can animate essentially any property of the view using the WinUI animation specifications. You can also define state triggers to have states applied depending on the dimensions of the window, for example, which is great when you're building a responsive application that needs to target multiple form factors like desktop, tablet, mobile phone. There's data binding. There's XBind, which gives you the ability to bind to functions in code behind. There's shapes, brushes, a whole kit of features, and then you can see many of them in action if you go to gallery.platform.uno, which is a demo running a whole suite of controls and showing off XAML features as well. It's available at that link for WebAssembly, and you can also download it on Android, iOS, and I think on the Windows Store as well through the stores. Another feature is that we don't only want to have you write your code and markup once. We also want you to only define the other assets in your application once. So if you have images in your application, you put those as well in the shared folder. If you have different versions of an asset for different device pixel densities, then you name them according to a standard naming convention, and Uno takes care of putting them in the correct places and in the correct names for each target platform. We do the same thing for localized strings. So if you have all your strings in your application defined in one place, maybe because you need to support different languages, then Uno takes care of converting those to the correct format for each platform. So you can reuse existing code. Of course, you can use portable .NET Standard 2 libraries. Since it's compatible with UWP, the great thing is that you can also recompile existing UWP libraries for Uno. So that's been a big help in jump-starting the ecosystem. So there's supported presentation frameworks like Reactive UI, Prism, MVM, Cross. There's the Windows Community Toolkit, which is maintained by Microsoft, which is compatible with Uno. There's been control suites for more advanced visualization of data released. Syncfusion released a set of controls, and recently Infragistics released some controls for Uno, and I'll be demoing one of those a little later on. Another feature of that takes advantage of the styling engine in WinUI is the Fluent UI design set of styles. So this was released with Uno 3 last year. It's Microsoft's modern design system that's used in Windows 10, and you can incorporate it into Uno with a couple of lines of code, and it's part of the Uno package itself because it's part of WinUI. We also made available the material design system. So this is a third-party NuGet. Well, it's an additional NuGet package now that's maintained by the Uno team. It's a set of styles for existing controls and also new controls that lets you use Google's material design system in your Uno app. So you add a few lines of code to your application initialization, and you have your whole app using the material design system. So you can see more info at the platform.uno website on that one. And if you like, you can certainly take control of the style of your application and make it look any way you like. And these are some of the apps that we've released with Uno at Inventive. So one thing I want to show you now is the Uno Playground. So I mentioned the gallery app earlier, which is showcasing ready to go XAML snippets. But if you want to try playing around with a piece of XAML and see what it does, we created the playground.platform.uno. So it's running a full text editor. It's actually running Monaco. So you've got code highlighting, and you've got rich text editing experience. And basically what you see on the right is what's defined here on the left. So I can edit the color of this foreground. It's going to complain because it doesn't pass, and then it's going to change the text for me. And I can also give the XAML a model to data bind to, which is the data tab here. So you can see down the bottom, this items control, the item source is bound to the tips field in the data. So if I add another line here, tips, Uno is covered in snow right now. There's a lot of snow here in Montreal today. So you can see that that updates in the model. And I can also, for example, edit this. Let's say I want to change my items control for a combo box. I can do a find and replace on that. So now I've got a combo box here with my items. So this is a great way of testing out XAML if you're curious what it does. There's also, you can start from scratch, or there's a bunch of predefined snippets that you can start from. And you can also bundle that up as a link and send that to somebody. So that's cool. So carrying on, a few more things I'd like to talk about. One is UI testing. So we're big believers at Uno platform in automated testing. And for UI-driven applications, the highest level of confidence you can get with testing is when you actually interact with the application in an automated fashion and verify that it does what you're expecting it to do. So we created the Uno.UITest framework. It's based on the Xamarin.UITest framework for iOS and Android. On WebAssembly, it's making use of Selenium. So it's basically a unified way of defining tests and running them on every platform. And like Uno, it's free and it's open source. And we use it in Uno itself to verify builds, and you can use it in your applications. SkiaSharp. So SkiaSharp is a package maintained by Matt Leibovitz. It essentially lets you create a canvas and drop it into your XAML visual tree, and then render to that canvas using the Skia rendering engine. So Skia is an open source low-level rendering engine that's maintained by Google, and that is itself supported on pretty much every platform. So that basically gives you a way to do low-level advanced rendering techniques with high performance. So for special situations, and you can easily integrate that with the rest of your XAML. And I'm going to talk about the controls released by Infragistics, which happen to be using SkiaSharp. So they've released those controls late last year. They're free to use, and I'm going to show you one now. So close this one. Open my Infragistics demo. So this is just a simple demo that's showing off the data chart control from Infragistics. So I'll run it on Windows first. It's easier to show you what it does than to try to explain it. So set the iPhone, set it to x86, run on Windows. So this is the chart down here, and we've got a picture, and all it's doing is hooking up to the mouse, and whenever the mouse moves, it takes the pixel underneath the pointer and saves the RGB value at that point, and then it's appending that value to a sequence of data which is being visualized in the chart down the bottom. So see, at the moment I'm over a dark area, so it's low pixel values. In the lighter area I get higher values. If I move over a blue billboard up here, there's more blue, so that all more or less checks out. And then in the chart itself, you can see that I've got mouse over states showing me about the data at that point on the chart. And then I'm going to run it on WebAssembly, so you can see it running there. So one interesting thing here is that that was quick because I had already built it. So you can see it's running here on WebAssembly. And again, I get the hover states when I move over the graph, showing me the value at each point. So one interesting thing here is that the control that's showing the picture is actually itself a Skia canvas. I think you could probably implement that just using a regular image in XAML if you wanted to, but this is an elegant way of doing it too. So I was playing with this earlier and I forgot to undo my changes, but I wanted to see if we can add another line to this chart. So I already got this one, which I'm gonna pretend is not there, but let's say that I want to see a combination of red and blue on the screen. So we'll add a new property here to the model class. I call it I'm just going to call it red blue, but let's in fact call it purple. So we'll add the red and blue, and we'll take the average, and then this is a code that I forgot to take out. So again, let's pretend this is not here. We'll copy one of the existing line series objects. We'll give it a different name so that it doesn't complain. We'll link to the purple value member path, and let's make it purple so it's easy to see what's going on. So it said brush purple. I'm not sure what the outline is, but let's change that as well. And then we'll run that again on WebAssembly. Yeah, so as I say, this is the picture explorer that's showing the picture is a SkiaSharp control, and it's hooking up the pixel hovered event, and it's hooking up to the pixel hovered method in the code behind, which is just adding the color from the event arcs to this set of data that's bound to the chart that you see down the bottom. So you can see it takes a little longer to compile on WebAssembly than on Windows, but here we go. Okay, so see, yeah, I can see my purple line now. If I hover over a kind of pinkish purplish area, yeah, we can see that the purple looks like it's the average of the red and the blue, like we would expect. So that's good. I'm happy with that. That's a good day's work of front-end development. So I don't have much more to talk about. Let me talk before I end about what we have in store in the immediate future for Uno. Some of you probably are keeping track of WinUI 3 and developments there. So for those who don't know, WinUI 3 is basically the next evolution of the API set that's part of UWP. So basically, you can define your application in exactly the same way, but it's now no longer bound to the operating system and not bound to a particular application model. So you can now define apps using the WinUI 3 contract that run in the kind of existing UWP sandbox model, or in the more permissive Win32 desktop model. And Uno is compatible right now with the WinUI 3 preview. So we're maintaining two versions of Uno, one that's compatible with the UWP one contract, and one that's compatible with the WinUI 3. It's not as hard as it sounds. The main difference is one of namespaces, but we're going to continue to track the WinUI 3, and we'll be there on day one when it gets a full release. We're adding more and more controls. We've released a lot of, we've added support for a lot of controls in the past 6 months, and we're adding more as we go. We're working on platform integrations, particularly on macOS and Linux. And we're also constantly working on performance, particularly for WebAssembly. Jerome, the guru in charge of Uno, often finds new weird corner cases in the performance of the WebAssembly runtime, and sends them to the team at Microsoft who works on the .NET runtime for WebAssembly, who are great at quickly finding fixes and coming up with arcane formulations in C to fix whatever the problem is.